This sample questions of exam paper is about momentum section under physics. As you see on the sketch, that toy cart is held together with a rocket on top and they are together moving in right direction at a constant speed of 2.5 meters per second. The mass of a toy cart is 20 kilograms, but of the rocket is not given, that is unknown. We turn to ignore the frictional effects on this movement. At a certain instant, the rocket was fired, which means now they are moving separately. The rocket moves at a speed 30 meters per second, and the toy cart at speed 0.6 meters per second. The speed of the toy cart is now smaller than before, which is caused by this firing action. This is because of this push and push action. What I mean is that when the rocket was fired to right, it exerted a pushing force to the left, or you may say it exerted a opposite pushing force on its stand, while at same time, the toy cart exerts a pushing force to the right. So, this push and push movement slowed down the speed of toy cart. And such theory or principle in physics, it is called or known as Newton's third law of motion. That law, if we may recap it, it states that if an object A exerts a force on the object B, then object B must exert a force of equal magnitude and opposite direction back on object A. I think 4.2 is answered now. On this 4.3, we have to calculate the mass of a rocket. We say, momentum before equals momentum after. The momentum before equals to a sum of masses times initial velocity. This m to subscript c is mass of a toy cart, and this m to subscript r is mass of rocket, same as their velocities. And the momentum after equals mass of toy cart times its velocity plus mass of rocket times its velocity. Then, we equate them as so. This 20 is the mass of a toy cart, this 2.5 is the velocity of them while they are together, this 0.6 is the velocity of toy cart after action, and this 30 is the velocity of rocket after being fired. Followed by grouping the like terms as such. This m to subscript r, it is mass of the rocket that we are on the way to find it. From this instance, all these together is finally giving us the mass of a rocket to be 1.38 kilograms.